Hello students, we have to learn sequence and series. Sequence, a set of numbers which are arranged in a definite, in a definite, in a definite order is called a sequence. Remember. Then see here, sequence is written as T1, T2, T3, dash dash Tn. Then see here, T1, T2, dash 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 Tn is called finite sequence, and T1, T2, dash 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 up to infinity is called infinite sequence. Remember. Then see here, sequences that follow specific pattern are called progressions. We have to learn three progressions. One as an arithmetic progression. Up to school level, already you learn arithmetic progression. Remember, up to school level, you learn arithmetic progression. Then geometric progression, and third as a harmonic progression. There are three progressions are present in our syllabus. Therefore, see here, first arithmetic progression. We carry the revision of arithmetic progression. Already you learn in 10th standard. Remember, arithmetic progression. Arithmetic progression. See here, what is its definition? Definition is very simple. For a sequence Tn. Remember, generally in this manner we write in curly brackets. Its nth term we write. For a sequence Tn, if difference between two consecutive terms Tn plus 1 T sub n plus 1 minus T sub n plus 1 minus T sub n is constant is called arithmetic progression, is called AP. AP means arithmetic progression. Remember, generally AP means arithmetic progression is written as a comma a plus d comma a plus twice d comma dash 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 a plus dash dash a plus n minus 1 into d, where a is first term and d is common difference. Common difference in which manner we obtain? T2 minus T1, T3 minus T2, T4 minus T3. They have all constant quantities present. That quantity or that number we recall as a common difference. Remember. Let's see here. Therefore, immediate this is T1, this is T2, this is T3. In this manner, this is T sub n. T sub n, T sub 1, T sub 2, T sub 3, T sub n. But generally we get as a T1, T2, T3, Tn, like that manner. Then say, therefore, T sub n is equal to T sub n equal to a plus n minus 1 into d. You remember this formula carefully. Tn equal to or T sub n equal to a plus n minus 1 into d, where a is first term and d is common difference. Remember carefully in your mind. T sub n equal to or Tn equal to a plus n minus 1 into d. Remember carefully in your mind, where a is first term and d is common difference. As well as you learn up to school level, that is the Sn. You know Sn means sum of first n terms, T1 plus T1 plus T2 plus dash plus T sub n or Tn. Remember. Then see here, formula for Sn already we learn. Sn is equal to S sub n or Sn is equal to Sn means sum of first n terms. Remember. Therefore S sub n equal to n by 2 in bracket twice a plus n minus 1 into d. Remember, into d. If we split up this part, that is a plus in bracket remaining quantity a plus a. Therefore a we carry here, and therefore another formula also we may derive. n by 2 in bracket a plus remaining quantity as a t sub n or tn. Remember, therefore s sub n equal to in this manner. As well as this result also you remember carefully in your mind. Sn or s sub n minus s sub n minus 1 equal to also tn. Remember carefully in your mind. All these results you remember. Already you evaluate examples. This is we carry revision here. Remember. The next progression, that is a geometric progression. Next progression as a these results you remember, because when we learn harmonic progression, that means harmonic progression means the reciprocal of arithmetic progression. Remember, therefore at that time these formulas you have to apply. For that purpose you must know arithmetic progression or their standard formulae. Remember. Then see here, this is new for you. Remember, geometric progression. Which progression? Geometric progression. Geometric progression. Geometric progression. In short, we let as a GP. Remember, in short, we let as a GP. GP means geometric progression. See here, for a sequence Tn, if ratio of two consecutive terms t sub n plus 1 divided by tn is constant. Remember, is constant. Is called geometric progression. Remember, that is very simple definition. For a sequence Tn, you remember this is a method of writing sequence. For a sequence Tn, if ratio of two consecutive terms Tn plus 1 upon Tn is constant, is called geometric progression. Let's see here. Geometric progression, or in short we write GP is written as remember, generally GP is written as in this manner: a comma ar square comma dash in this manner. Remember. Then see here r as a where a is first term. Remember, where a is first term and r is common ratio. Remember, r is common ratio. Common ratio in which manner we obtain? That is ratio of two consecutive terms we take. That is T2 upon T1 or T3 upon T2 or T4 upon T3. They have all these ratio have same solution. That quantity we denote by r, that is common ratio. Remember carefully in your mind. Then see here, if we generalize, then see here, this we have to obtain formula for Tn of a GP. That is very simple. See here, T1 we generalize that part and we obtain the formula of Tn or T sub n. That is T1 equal to or T sub 1 equal to A. We write in this manner: A into r is to this suffix as a 1 minus 1. Then we get here r is to 0. R is to 0 means 1. Therefore we get A. Remember. Then here T sub 2 equal to AR. See here, this is second term. T sub 2 or T2 equal to AR. That is A into r is to this suffix we carry 2 minus 1. This minus 1 is fixed. In this manner, see here, therefore you carry simplification. Therefore A into r is to 2 minus 1 means 1. Therefore AR we get. By same way, T3 equal to A into r square. Therefore see here again we write in this manner: A into r is to this suffix 3 minus 1. And therefore in this manner, therefore immediately write in general, therefore see here, T sub n equal to or Tn. T sub n equal to A into r is to this suffix as a n and minus 1. This minus 1 is fixed. Therefore formula for GP we construct. Therefore you remember formula for GP for Tn equal to A into r is to n minus 1, where A is first term and r is common ratio. Common ratio in which manner we obtain? T2 upon T1 or T3 upon T2 or T4 upon T3. Remember in this manner, you remember this part. Then we evaluate some examples, remember. Then we evaluate some examples here. Some examples we evaluate by using these, by using definition as well as formula for Tn. We evaluate examples here. First example we carry. First example we carry. First example we carry. Verify. Here, verify. Example we take. Example verify. Verify whether. Verify whether 1 comma verify whether 1 comma minus 3 by 2 comma 9 by 4 comma minus 27 divided by 4 dash is a GP. Remember, we have to show here is GP. If GP, then find T9. Then find T sub 9 or T9. Remember, this is our example. This example we have to evaluate. First, verify. We have to verify this is GP or not. Remember, if GP, then find T9. Remember, that was here solution. That is very simple. Given part right. Given that is 1 comma minus 3 by 2. 1 comma minus 3 by 2 comma 9 by 4 comma minus 27 divided by 4. In this manner dash up to infinity. That was here. This is T1, this is T2, this is T3, this is T4. Dash. Therefore immediate we have to show this is GP. Therefore we have to take ratio. That was here. Therefore T2 upon T1 equal to T2 as a minus 3 by 2 divided by 1. Upon we get minus 3 by 2. Then here by same way T3 upon T2. T3 as a 9 by 4 whole divided by minus 3 by 2. Then here 3 cancel. This positive divided by negative we get negative. 3 cancel 3. Then 2 cancel. Therefore 3 by 2. Here we get R as a 3 by 2. Remember, therefore here A means first term as a 1 and R common ratio we denoted by R. Remember, R as a minus 3 by 2. Hence here we get common ratio. Therefore immediately we get ratio of two consecutive terms. We get ratio of two consecutive terms is constant. That is R is equal to minus 3 by 2. Therefore given sequence is geometric progression. Remember, we show there in this manner. Why we write this is geometric progression? Because ratio of two consecutive terms is constant. That is R is equal to here minus 3 by 2 minus 3 by 2. Therefore immediately we decide that is geometric progression. Remember. Then say next part, if GP, this is GP, then find T9. Then to see immediately we have we learn formula for Tn. We have T sub n or Tn equal to A into R raised to n minus 1. Then say here therefore put n equal to 9 we have to substitute because T9 we have to obtain 9th term of this GP we have to determine. Therefore T sub 9 equal to A. What is A here? 1 in bracket R. What is our R? That is minus 3 divided by 2. Minus 3 divided by 2 bracket is to 9 and therefore minus n we get because minus is to odd. Therefore minus 3 upon 2 bracket is to 9. This is our solution. In this manner we evaluate this example. Remember, in your mind carefully, there is nothing. Then here next example we carry. Therefore results. You must know formula for Tn as well as simplification we have to follow. Then immediately we can evaluate respective examples. Then here this example we carry. Which term of sequence? Example number 2. Which term of sequence that is under root of 3 comma 3 under root of 3 dash is 243 that is in which term there is a 243. That part we have to determine. That is the value of n we have to obtain. Therefore, see here, this is first term, this is second term, this is third term, like that as we have to obtain this is in which term there is 243. That part we have to obtain. Therefore, see here, solution in which manner given here, that is a given part we write under root of 3 into under root of 3 dash 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 in this manner, remember. Therefore, a equal to under root of 3 and r we have to obtain. R equal to, we know, T2 upon T1. T2 upon T1. R equal to T2 upon T1, remember. T2 upon T1. Because here T2 upon T1. Then here is equal to, because if we observe, we do not obtain the difference because 3 minus under root of 3 or 3 into under root of 3 minus 3, that is common difference we do not obtain, therefore that is not AP. Therefore we observe that is GP or not. Therefore see here, T2, what is our T2? T2 as a 3 divided by T1 as a under root of 3. We know 3 means under root of 3 into under root of 3, that part already we know. Therefore after simplification under root 3 cancel, therefore 3. Again see here, R is equal to T3 divided by T2, remember, because a ratio between two consecutive terms we obtain, that is T3 divided by T2. What is T3? 3 into under root of 3 divided by, what is T2? 3. 3 cancel, again we get under root of 3. See here, under root 3 we get ratio is constant, therefore automatically this is geometric progression. In this manner we obtain. Therefore see here, which term of a sequence, therefore we know formula, see here, we have formula for T sub n of GP. We know, just we learn. Therefore see here, T sub n or Tn equal to A into R raised to n minus 1. See here, given part Tn we let, Tn equal to 243 we let. We imagine this is nth term. Remember, we imagine this is nth term, Tn, because that term we have to obtain. In which term there is 243. That part we have to determine, remember. Therefore, see all quantities we replace. What is Tn? 243. What is A? A already we mentioned under root of 3. What is R? R also under root of 3. Bracket raised to, R also under root of 3. Bracket raised to n minus 1. Let's see here. What is its power? 1. If base and an index, this plus 1 minus 1 cancel. Therefore, remaining part 243 equal to under root of 3 bracket raised to n. Remember, we have to carry simplification. We know we carry simplification. This is here 3 raised to values of indices n by 2 we get. Values of indices n by 2 we get. Let's say this quantity also we may represent in terms of 3 power 3 raised to. We know this is 3 raised to 5. This is 3 raised to 5. Remember, because 3 raised to 4 is 81. If we multiply 81 by 3, then we get 243. Remember, therefore 3 raised to 5 equal to 3 raised to this 1 half into n means 3 raised to n by 2. And we know if base same, then index also identical, or same. If base same, then index also same. Therefore 5 equal to n by 2, and we transfer 2 on this side, and therefore n equal to 10. Therefore 10th term as a 200, which term of sequence, that is 10th term of GP is, therefore solution we write, therefore 10th term of GP means geometric progression, is 243. In this manner we evaluate this example. Remember, there is nothing, remember carefully in your mind, only simplification and standard formula we apply. Formula for T sub n or Tn equal to A into R raised to n minus 1. R in which manner we obtain, that is a ratio of two consecutive terms we carry, and immediately we evaluate, remember. Then say next example we carry, next example for sequence, third number, for sequence GP, for GP or for sequence GP, anyway, for sequence GP, here for in this manner that example is present, for geometric progression, if A equal to 3, T7 or T t sub 7 or t7 in manner 192. Find r means common ratio. Remember, find r means common ratio. Remember, that is very simple. Solution. First we write given part, given, which is given quantity a means first term, and we have to provide t7 equal to 192. Then here we know formula for tn, therefore immediately write we have t sub n or tn equal to a into r raised to n minus 1. We have to given t sub 7, therefore that is t7. Therefore we replace, put n equal to 7 on both sides, we replace, therefore t sub 7 equal to a. What is our a? A also we have to provide 3 in bracket. R we have to determine that quantity, r we have to determine. N as a 7 minus 1, remember, r is to 7 minus 1. Then here t sub 7 already we have to given, that is 192 equal to 3, r is to 6. Then we transfer on this side, therefore see here 192 divided by 3 equal to r is to 6. Then we get, see here, that is r is to 6 is equal to, that is 3 6 18. Therefore, and here remaining quantity 1 and therefore 4. And we know therefore r is to 6 is equal to 2 is to 6. If power same, then base also same. Therefore r equal to 2 we obtain. Remember, in this manner we evaluate this example, that is common ratio. Here we have to ask in this manner. Only this formula we apply. Formula for nth term of Gp, that is t sub n equal to a into r raised to n minus 1. Here we replace n equal to 7 because t7 we have to given. In this manner we evaluate this example. Remember carefully in our mind. Then see here next example number 4 we evaluate. Example number 4. See here example number 4 we evaluate. See here, that is very simple. Example number 4 we evaluate. For what values of, see here, next example we carry for what value of x, the terms but for what value of x, the terms 4 upon 3, comma x, comma 4 upon 27 are in GP. GP means geometric progression. In this manner, that means value of x we have to obtain. Remember, value of x we have to obtain. We know already we have to provide 3 are present in GP, in geometric progression. In which manner we determine geometric progression? That is, geometric progression means a ratio of two consecutive terms is constant. Therefore, here this is T1, this is T2, this is T3. In this manner, here solution. Here we write here T1 equal to T sub n or T1 equal to 4 by 3, T sub 2 equal to x here, and T sub 3 equal to 4 divided by 27. Then here this is GP. Already we had tried. This is R in GP. Therefore thus T2 upon T1 equal to T3 upon T2. Given is GP, because given part as a GP. Therefore remember in this manner. Therefore here what is T2 our? T2 as a AX divided by T1, 4 divided by 3 equal to T3. What is our T3? T3 as a 4 divided by 27 divided by T2. T2 as a x. Then I transfer x on this side. I can simplification only. X into x square. Already 4 upon 27. And this goes to numerator. Therefore into 4 upon 3. And after simplification x square is equal to, that is 16 divided by 81. And we know that is x square is equal to 4 divided by 9 bracket square. And therefore here square, therefore base also same, because power is same, therefore base is same, therefore x is equal to 4 divided by 9. In this manner we obtain the value of x. Remember, in this manner we evaluate this part. Remember, Let's see here. Then next part, that is this type of example is present. We evaluate next example. See here. Next example.